This is an example of how to find standard deviation of a sample. The abbreviation for sample standard deviation is S. The formula is the square root of sigma x minus x bar quantity squared divided by n minus 1. Sigma we know means to sum or to add things together. X bar is the sample's mean, which would have to be a calculation you do before you begin calculating standard deviation. N is the sample size of the data that you're working with. So if your data is 1, 2, 5, 8, 9, then we would have 5 numbers in our data set, so n would be equal to a 5. To calculate x bar, you would add all of these numbers together, so that's going to be 10, 20, 25, and divide by the number of points in your data set. And so you get an x bar of 5. Standard deviation is looking at what on average is the distance each one of these data values actually is from being 5, which is the expected value. So we take each data value, 1, 2, 5, 8, and 9, and you subtract the expected value or the standard, the sample mean. And you can get negative numbers if the value that you have is below average. You could get the average itself, or you can get positive numbers if the value you're working with is above average. Because we have some negative numbers, it could allow, and it should, these subtraction answers should always total 0. So what you want to do on your next step is to square each of these values. And that's going to make them all positive, which will take care of the zeroing out scenario that could happen otherwise. You then roll into your addition step. And then you divide by 1 less than the number of data points that you have. So we have 5 data values here, so we're going to divide by 4. And we get 12.5. And this is actually a name of a calculation in statistics. It's called the sample's variance, which is abbreviated S to the 2nd power, because we've squared all of these numbers. Any units that you would have on this value would be squared. So if you have dollars, it would be dollars squared. If you have TVs, it would be TVs squared, which really is difficult to make sense of. And so what we do is we go ahead and undo the squaring step that was done to remove negatives on this final step here, and that's what's going to give you your standard deviation value. And so you would calculate the square root of 12.5. And that would give you approximately 3.5355. And make sure you are rounding out to 4 digits. That has been our common practice throughout this class. And since we undid the squaring step, any labels that you put on this number are going to be just regular units. So 1, 2, 5, 8, and 9 on average are 3.5355 units away from actually being the 5, which was the expected value. This tells us how much spread or variation there are in our numbers from being what was expected, which was that sample mean value of a 5. The more variance and standard deviation you have in a data set, that means that your data values are going to be more spread out. And so that means you have more variation. If you have more variation in your data, that means that your data is inconsistent or might not be reliable in receiving an answer of 5 as your standard or your sample's mean, the value you expect to get most of the time. As your standard deviation gets smaller, that's an indication that your data values, when you look at them, are actually going to be closer and closer to this actual 5. So there's less spread, which means that you have more consistency and perhaps reliability in your data collection process.